let's get going, ladies and gentlemen. Today we are going to be learning about different sampling methods and how to do random with our digit table. We're going to start off, though, with a little bit of activity that I want you guys to do. So we're going to see how much do fans actually love Justin Timberlake. And so what you're going to be doing here is you are going to be kind of doing this by yourself right now. But this represents seats in a theater or whatever, a show, watching Justin Timberlake perform on stage. And it says, take a simple random sample of 10 fans. Now, a simple random sample is something that is completely random. Everyone has a likely chance of getting picked. And so it says you can use whatever way you'd want to get a random sample. I highly recommend either using your calculator, which since I'm not there, I'm not going to show you, or you can do something even easier. You can just come to a random number generator and, say from 1, I just Googled random number generator, 1 to 10, generate, and it should generate a random digit for, now with this, I see there are, 5 that way and like 10 that way, so there's 50 seats. You might want to assign each seat a number and then put a check through the ones that you would sample. Okay. Method 2 says randomly choose 2 fans from each horizontal row, so you'd only pick 2 fans from this row, pick 2 fans from this row, pick 2 fans from this row, right? And method 3 says choose 1 fan from each vertical row. So you'd pick 1 fan here, 1 fan here, 1 fan here, 1 fan here, and you need to randomly choose them, all right? Then talk about why you think which is best. Then you're going to move to the next page, and you're going to see exactly what your data gives you. Find out the average fan enjoyment for each sample method, and then you're going to plot them on the whiteboard. And then copy down what everybody's answers are, and you'll see which way do you think is best, method 1, method 2, or method 3. Okay? All right, so just to kind of give a little input on exactly how the different sampling methods does make a difference. All right, so read through this very carefully, and like I said, draw your final results up on the board after you've gotten to page 2. Moving on from there, though, we're going to talk about how to sample good. What would be a good sampling, all right? And one of the most common ways to sample really good is to do a simple random sample, also known as an SRS. You're going to see this abbreviated SRS an awful lot. That means simple random sample, everything has an equal chance of being picked. All right, so just so you know, sometimes some people say, I'm going to randomly do a simple random sample. I'm going to have everybody get in a line, and I'm going to go, all right, 1, 2, 1, 2, 1, 2, 1, 2. Okay, all my 2s are the ones who get picked. That's not simple random sample. Not everyone had a chance of being picked, because the first person, the third person, the fifth person had no chance of being picked because they were ranked as a 1. A simple random sample lets everyone have a same chance, an equal chance to be picked. And so how do we do this? One of the best ways is to put names into a hat and pull a name out of a hat and say, Johnny, Susie, Teddy, okay, Brittany. Okay, so that's a really nice way to do it. Otherwise, you can use your calculator and assign everybody a number. Like if you have 30 individuals, you would probably go from 1 to 30, right? And then in your calculator, you can pick out, 6 people with no repeats, right? From there, that would also be. And then we also have this thing called a random number table. And that one you have to be a little bit more careful on when you're assigning numbers, because if we have 30 people, we would want to make sure we have double digits for everything. We can't just assign it 1 because that gets a little messy. But if you're doing a random number table, which is actually found on the back page of your notes, of your yellow formula guide, the very back page is a table D random digits, and I don't know who got paid to make random digits, but these are all completely random. One number doesn't have any more likelihood than the other number of being picked, and you can use that. And let's actually just show you how you would do that in the next paper. So a table of random digits is all digits from 0 to 9. There isn't a 10 because that would be going into 2 digits, right? Because 10 would be a 1 and then a 0. Okay. And each one is independent, so just because one is a 2, the next one doesn't mean that it can't be a 2, right? It's got the same likelihood of being a 2. And so we can choose a random sample from that way. Now, how could we use our table of digits? So if you look at your table D, line 130, to choose simple random sample of 4 hotels. So we have 28 hotels listed here, right? Okay. And so we assigned everyone a number. Now notice why we did double digits. Why we wouldn't just do Aloha Kai? Because if we're looking down this list, this one right here, is this Aloha Kai, or is this 16, which would be Radisson, right? So we assign everything a double digit, and therefore we know that when a 0 and a 1 happens, that's a 1. When a 1 and a 6 happens, that's going to be a Radisson. All right, so it says use the table at line 130. So going right to line 130 and pick out which ones we would pick. So the first one is 69. Well, 69 is not up there, so we are going to avoid all of 69. The next one is 05. 05, that is Beach Castle. Then we do 16, which is Radisson. And then 48, which isn't there, so we toss them both out. Just toss it out. And then we have a 17, which is Ramada. All right? Oops. And we need one more. We got 87, which is too high. We have a 17 again, but we already picked that, and we want 4 different hotels. So we're going to cancel out 17. 40, there's not a 40. There's not a 95. There's a 17 again. I'm going to toss 17 out because we've already interviewed them. 84 gets chucked out. 53 gets chucked out. 40 gets chucked out. 64 gets chucked out. 89 gets chucked out. 87 gets chucked out because we don't have any of these. And finally, the last one would be 20, which is C Club. All right. So that's basically how you would use your normal, your table of random digits. If you wanted to use this, sometimes you might catch a short answer question that asks you how to do that. Don't be afraid to toss ones that you've already used out. And then you just move to the next row. If you've already used up a row and you haven't gotten anything, just move on down to the next. And then you move on to row 131. All right. So, other sampling methods. All right. This is probably the part where most people struggle, is knowing the difference between these. Okay, so simple random is basically everybody's got a shot, and I can sample from the whole population. Okay. Stratified separates things into groups. And they say like groups, but I don't really like to always think, it's not always like groups. I mean, I guess maybe by some way they're like groups. But way back when, we used to have prides that, or it would be like by grades, sorry. So it'd be like freshman, sophomore, junior, and then senior. All right, so say we have a couple different groups. And then we take a random sample, right, an SRS, from each group. Okay, so this way we make sure we have the same amount. So let's say we wanted 40 people to be interviewed. Well, I would want 10 from the freshmen, 10 from the sophomores, right? And I would do a random sample from each group. That's what strata is, okay? Is kind of like groups. So Sorry, that's getting a little ugly. This is a little glitchy. It's a little glitchy today. Okay. So when we talk about this over here, when we did this, this Timberlake thing, like I said, it's glitching out. And it says randomly choose 2 fans from each row. So each horizontal row, that would be a strata, right? And we're taking a random sample of 2 from each. So this is a strata. Here, this says take 1 fan from each column. So each column would be the strata in the third method. And you're only taking 1 away. Okay, so that's an example. I know I have some different examples that you can write down in your notes. So I've kind of given you a couple different ways. So strata is separating things into like groups and then taking random samples from each group so you have a equal representation from each group. Okay, and the reason why we do that, it would be like if I was to ask everybody and put out a survey and say, man, what do you guys think of block periods, right? And seniors, I mean, for crying out loud, we all know seniors aren't going to care what happens next year for block or not block. And so they might just be like, yeah, screw everybody else out. You know, let's all vote and say we love block classes. And then what if like 30 of the 40 people randomly happen to be seniors? Oh, great. Now our data is really messed up, right? Okay. The other one is clusters. All right. And like I said, I'm a little glitchy here. Clusters are also getting into groups. Okay. And I'm going to give you a bad representation of a cluster just because we just did this. So this is also groups. Okay. Like freshman, sophomore, junior, senior. Okay. But cluster basically says, all right, we're going to do, so these are like groups. We only have time to sample 1 of these groups. So we say, all right, we're going to do this as 1, this is 2, this is 3, this is 4. Come on, why isn't 3 popping up? There we go. Okay, and then we say, all right, random calculator, bloop, oh, 2. So group 2 picked, we're going to sample all sophomores, and we just sample everybody from the sophomores, and we completely forget about freshman, junior, senior. Now, this would be a bad way because why would we only care about what sophomores think in the school? Another illustration of this was a couple years back. We had prides where they had freshman, sophomore, junior, and senior in the pride. So every grade was represented in one pride. So this would be like pride 1, pride 2, right? Pride 3. Okay, and the big difference here is that, you know, obviously it's going to keep going on. The big difference is that with clusters, we randomly pick a couple. So maybe we'll say, you know what, I want to know something, but I don't have time to do everybody. I'm going to sample 2 random prides. So I would do a random digit, maybe I'd get a 1, and the next one would be maybe a 4, and I would sample everybody in that group. Okay, so clusters are into groups, and I sample everybody, whereas strata are like groups, but we take a random sample from every group. Okay, big difference there. We have a minute to discuss the last one. Whew. You know what? I'm going to do this tomorrow. We're going to talk about systematic tomorrow, and we'll see how we do. Okay, so ladies and gentlemen, you can get going on some homework, I'm sure. The homework that is assigned to you is these. I think you could probably get through like 17 or so. And then enjoy the video. You guys are going to be watching United Stats of America here today. So, hope all goes well. Have a good one. Bye.